Hello everyone, welcome to my presentation. In this presentation, we will discuss about frequency modulation, means FM modulation, and introduction of frequency modulation. In this presentation, we will discuss following contents: definition, types of frequency modulation, advantages, disadvantages, application, and conclusion. Definition of frequency modulation. Frequency modulation is the process by which the frequency of a carrier signal changes with respect to the modulating signal. FM modulated signal is a non-linear function of modulating signal. Types of frequency modulation. First type, narrowband frequency. Narrowband frequency modulation means that the FM modulated wave has a narrow bandwidth. The maximum frequency deviation is 3 kHz. Second type of frequency modulation is wideband frequency. Wideband frequency modulation means that the FM modulated wave has a wide bandwidth. Modulation frequency range from 30 Hz to 15 kHz and the minimum deviation is 75 kHz. Advantages of frequency modulation. First, the amplitude of the frequency modulated wave does not get affected. Second, frequency modulation decreases the noise, hence there is a significant increase in the signal to noise ratio. Third, we can also reduce the noise by increasing the frequency deviation. Fourth, it is also reduces the interference by the adjacent channels through guard bands. Advantage of frequency modulation. First, FM cannot cover large area. Second, transmitting and receiving equipment of frequency modulation is complex and expensive. Third, generally wider channel 200 kHz are required for FM. Fourth, the antennas for FM need to be closely placed for better signal. Application of frequency modulation. First, it is used in video cassette recorders. Second, it is used to store luminous part in VHS. Third, it is work as limiter and also help to remove pre-echo. 4. It is used in radio broadcasts and satellite TV. 5. It is used for audio frequency synthesis. 6. It is used to broadcast analogous TV sound. Conclusion. Frequency modulation is a very important subtype of modulation. It forms a very integral part of our day-to-day life. It is very frequency used in radio broadcasting and satellite TV. Frequency modulation has both advantages and disadvantages, just like any other modulation system. It provides a high sound to noise ratio with very low interference. The reason why they used in radio broadcast. One of the most significant drawbacks that is does not cover a large area and the system is very costly and complex. Unacademy and thank you.
Hello friend, we are study about the bandwidth and information capacity. First one is bandwidth. Bandwidth refers to the range of frequencies over which a signal or a communication channel can transmit data effectively. It is a fundamental concept in electronics, telecommunication and networking. The bandwidth of a signal determines the amount of the data can be transmitted per unit of time, and it plays a crucial role in determining the speed of and capacity of a communication system. First one is bandwidth for signals. For analog signals such as audio or radio signals, bandwidth refers to the range of frequencies that contain most of the signal's energy. In the context of audio signals, bandwidth determines the range of audible frequencies. Second one is relationship with data transmission. The greater the bandwidth, the higher the data transmission rate. In digital communication, the data rate is measured in bits per second or its multiples like kilobits per second or megabytes per second. Second one is information capacity. It is the maximum rate at which information can be reliably transmitted over a communication channel. First theorem is Shannon-Hartley theorem. The Shannon-Hartley theorems state that the maximum information capacity of a communication channel measured in bits per second. Second one is channel capacity limitation. First one is noise and interference. Real world communication channels are subject to noise and interference, which reduce the effective SNR and limit the achievable data rates. Second one is bandwidth limitation. The channel bandwidth imposes a physical constraint on the data rate. Expanding the bandwidth can lead to increased capacity, but it may not always be feasible due to regulatory restriction and spectrum availability. Third one is signal processing complexity. Achieving higher data rates often requires sophisticated signal processing techniques, which may introduce complexity and cost.
Hello everyone, my name is Rushali Jadhav. My topic name is Classification of Electronic Communication Systems. First point is wired and wireless communication. First parameters: physical connection, using cables or wires in wired communication, using air or free space, or sometimes number of physical connections required in wireless communications. Second parameter: data transfer speed, higher speed in wired communications, less speed or slowly data transfer speed in wireless communication. Third parameter: mobility, less mobile or movable in wired communication, always movable in wireless communication. Fourth parameter: reliability, more reliable and stable in wired communication, prone to interference in wireless communication. Fifth parameters: installation and maintenance, difficult to install and maintain in wired communication, easy to install in wireless communication. Sixth parameter: security, more secure in wired communication, less secure in wireless communication. 7 parameters: cost, more costly in wired communication, less costly in wireless communication. Second point: unicast and broadcast communication. First parameter: definition, one-to-one communication in unicast communication. Example: telephone, mobile, telegraph. One-to-one all communication in broadcast communication. Example: radio, TV, news portal, satellite communication. Second parameter: data transformation, one sender to one receiver in unicast communication, one sender to multiple receiver in broadcast communication. Fourth parameter: network traffic, generates less traffic in unicast communication, generates more traffic in broadcast communication. Fifth parameter: efficiency, more efficient in unicast communication, less efficient in broadcast communication. Sixth parameter: security, more secure in unicast communication, less secure in broadcast communication. Sixth parameter: cost, more costlier in unicast communication, less costlier in broadcast communication. Third point: simplex, half duplex and full duplex. First parameter: definition, one-way communication flows in single direction in simplex. Example: TV, radio. Two-way communication but not simultaneously in half duplex. Example: walkie-talkie. Two-way communications simultaneously in full duplex. Example: mobile communication. Second parameter: data flow, unidirectional from sender to receiver in simplex, bidirectional but not simultaneously in half duplex, bidirectional and simultaneous in full duplex. Third parameter, efficiency. Very efficient in simplex, less efficient in half duplex, highly efficient in full duplex. Fourth parameter, cost. Less costly in simplex, more costly in half duplex, high costly in full duplex. Thank you.
Welcome friends. We have seen in this PPT the classification of electronic communication system, unicast communication and broadcast communication. Unicast communication. Unicast is basically a single direction request sent from one host to another, and only the two hosts interact over the established route, that is from one source to another source, that is one to one communication. The example of this unicast communication is face to face communication and email. Broadcast communication. Broadcasting is the distribution of audio or video content to a dispersed audience via any electronic mass communications medium, but typically one using the electromagnetic spectrums in one to many model, that call these one to all communications. The example of broadcasting communication is radio, public address system. The comparison between unicast communication and broadcast communication. The first one is communications type. Unicast communication is a one-to-one communication system, and broadcast communication is one-to-all communication. Data transmission. Data transmission is transferred from sender to receiver only, and broadcast communication transferred from one sender to many receivers. Network traffic. Network traffic. Less network traffic as data is sent only to one receiver, generates higher network traffic as data is sent to all devices. Efficiency. More efficient as it minimizes unnecessary data flow. Less efficient due to potential network congestion and more data flow. Security. Generally more secure as data is sent to a specific receivers. Less secure. Broadcast communication is less secure as sensitivity information is sent to all devices. Scalability. In unicast communication, scalable and suitable for large network as data is triggered to specific devices. Broadcast communication may not scale well in larger networks due to increased network congestions. Example: unicast communication, cable communication, mobile communication, email services, etc. And broadcast communication, radio, public address system, video conference, TV, etc. Thank you.
Welcome to PPT by Pranav Alvekar. PM modulation. In phase modulation, PM, the carrier signal changes its phase with the changes in the message signal amplitude. FM and PM are types of what is called a angle modulation, as given below the diagram. PM modulation. FM and PM are interrelated. One cannot change the other changing. In FM, the frequency of a carrier signal deviates from its center frequency amount that is proportional to the message signal amplitude. In PM, the frequency of a carrier signal changes by an amount that is proportional to the message signal amplitude and frequency. PM modulation. FM requires the carrier's frequency to deviate both above and below its center frequency. During the process of frequency modulation, the peaks of each successive cycle in the PM modulated waveform occur at times other than they would if the carrier were unmodulated. This is actually an incidental phase shift that takes place alone with the frequency shift in FM as given below the diagram. PM modulation, just the opposite action takes phase modulation. Notice that time period of each successive cycle varies in the modulated wave according to the audio wave variation. Sine frequency function of time period per cycle. We can see that such a phase shift in the carrier will causes its frequency to change as given below the diagram. PM modulation. In frequency modulation, the frequency of a carrier signal deviates from its center frequency by an amount that is proportional to the message signal amplitude. FM uses the message signal M to vary the carrier frequency within some small range about its original value. Thank you for watching the video.
Welcome to this presentation. Presentation is presenting by Sneha Manoj Jadhav, class SYETA. I am going to present the topic frequency modulation. Introduction. The presentation provides the information about frequency modulation. The presentation will cover following topics: history of FM, basics of FM, advantages of FM, disadvantages of FM, mathematical representation of FM, and applications of FM. Basics of FM. FM modulation is a technique of encoding information on the carrier wave by varying the frequency of the wave. The information signal is used to modulate the frequency of the carrier wave. The resulting signal has constant amplitude and a varying frequency. The frequency deviation is proportional to the amplitude of the modulating signal. So there are some advantages and disadvantages of frequency modulation. Firstly, we see the advantages of FM. FM modulation has several advantages over other modulation techniques. FM signals are less susceptible to noise and interference than AM signals. FM radio has better sound quality and stereo sound. FM is also used for mobile communication such as two-way radios and cell phones. Disadvantages of FM. FM modulation also has some disadvantages. FM requires a wider bandwidth than AM, which limits the number of the channel that can be broadcasted. FM signals are also more affected by atmospheric conditions like rain and snow. FM is also more expensive to implement than AM. Now we see the most important part, mathematical representation of FM modulation. FM modulation can be mathematically represented as a function of time and frequency. The carrier wave frequency is represented by cos 2 pi fct, where fc is the carrier frequency. The modulating signal is represented by cos 2 pi fmt, where fm is the modulating frequency. The FM modulated wave is given by the following equation. There are some applications of FM modulation. FM modulation is used in a wide range of applications, including radio broadcasting, television broadcasting, wireless communication systems, and radar systems. It is also used in navigation systems such as GPS and in medical imaging equipment as MRI machines. Lastly, the conclusion. From this presentation, we conclude that FM modulation is a powerful technique for encoding information onto a carrier wave. It has many advantages over other modulation techniques and is widely used in various industries. However, it also has some challenges that must be addressed to ensure high quality transmission. In this presentation, I tried to give the deep information of a frequency modulation. Hope you will like it. Thank you. Hello, welcome to Analog Communication. My name is Gayatri Patil. Today's topic is Introduction to Electronic Communication System. Then the first one is define unicast communication and broadcast communication. Second one is compare unicast communication and broadcast communication. Then the define is unicast communication. Unicast is the term used to describe communication where is a piece of information is sent from one point to another point. There is just one sender and one receiver. The next one is define broadcast communication. Broadcast communication is have single sender and transmitted to all endpoint on the network is called broadcast communication. Then we see the compare unicast and broadcast communication. Unicast communication. Then I read all point of unicast communication. First one is one-to-one communication. Second is transform from sender to receiver only. Third one is there is less traffic. Fourth one is more efficiency as it minimizes necessary data flow. Then fifth one is generally more secure. Data is sent to a specific recipient. Then sixth one is data is sent only to one recipient. The next one is broadcast communication. First one is transform from one to many receiver. Second one is one to all communication. Third one is generate higher network traffic. Then fifth one less efficient. Then sixth one less secure as sensitive information is sent to all device. Then next we see the flowchart of the unicast and broadcast communication. Unicast communication is one-to-one communication and broadcast communication is one-to-all communication. So today we learn complete the unicast communication and broadcast communication. I hope you understand this point. Thank you.
SSBSC Single Sideband Suppressor Carrier Transmission. SSB means single sideband, that is only one sideband. If the carrier is suppressed or removed, the modulation is called as SSBSC, Single Sideband Suppressor Carrier. Otherwise, the modulation is termed as SSBC, Single Sideband with Carrier. SSBSC is used to transmit audio signals such as speech signals and radio waves. SSBSC transmission does not require an additional sideband to recover a signal. A single sideband is enough for the transmission. It results in a low spectral range and low bandwidth, which increases the efficiency of the signal. SSB is commonly used in long-distance transmission of speech signal. The bandwidth of the speech signal lies in the range of 300 Hz and 3400 Hz. The maximum space between the two channels in SSB can be 4000 Hz. We have discussed that a baseband signal can be recovered from double sideband suppressor carrier DSBSC by multiplying it with the same carrier second time. Now, what happens if there is only one sideband? Is the process of baseband recovery the same? Let's discuss. The spectral components of a baseband signal generated two sidebands in DSB of frequency omega plus omega c and omega minus omega c, where omega c is the carrier frequency and omega is a baseband frequency. If we filter out the lower sideband by multiplying it with the carrier signal, we get the frequency of omega plus 2 omega c. If we filter out the upper sideband by multiplying it with the carrier signal, we get the frequency of 2 omega c minus omega. In both cases, the baseband signal can be easily recovered. Hence, recovering the baseband signal from a single sideband is possible. It saves spectral space, which is an added advantage of SSB modulation. Two signal modulation systems are required to occupy the spectral range in SSB, which was previously occupied by the single DSBSC transmission system. The single sideband transmission system consists of only one sideband and a single sinusoidal. Here, the diode modulator to recover the baseband signal cannot be used. There is no such amplitude variations to which the modulator can respond. A pictorial representation of the generation of single sideband is shown below, where DSB is double sideband, USB is upper sideband, LSB is lower sideband. USB shows the SSB modulation when the upper part of the sideband is filtered out. LSB shows the SSB modulation when the lower part of the modulation is filtered out. There are so many advantages of SSBSC. Advantages of SSBSC: high efficiency. SSBSC has efficiency of 100%. It is the most efficient amplitude modulation. Less spectral space. SSB occupies less spectral space due to the presence of only one sideband. Low signal fading. SSB has low fading compared to other modulation type because of a narrow bandwidth. DSBSC has wide bandwidth and thus suffers from high fading. Low power consumption. SSB consumes low power due to presence of suppressed carrier, high efficiency, and single sideband. Disadvantages of SSBSC: complex receiver and transmitter. The SSBC generation is complex and requires complex circuitry at the transmitter and the receiver. SSB avoids bandwidth increase, due to which the power wastage occurs. It further leads to tuning. SSBSC also requires high frequency stability, transmitter and receiver, otherwise the signal quality may get affected. Thank you for watching.
Hello everyone, my name is Kiran Patil and we are going to learn about SSBSC transmission. Here is an overview of whole session. SSBSC transmission. SSB means single sideband, that is only one sideband. If the carrier is suppressed or removed, the modulation is called SSBSC, that is single sideband suppressed carrier. Otherwise, the modulation is termed as single sideband with carrier, which is SSBC. SSBSC is used to transmit audio signals such as speech signals and radio waves. SSB transmission does not require an additional sideband to recover the signal. A single sideband is enough for the transmission. It results a low spectral range and low bandwidth, which increases the efficiency of the signal. SSB is commonly used in long distance transmission of speech signal. The bandwidth of speech signals lies in the range of 300 Hz and 3400 Hz. The maximum speed between the two channels in SSB can be 4000 Hz. A pictorial representation of the generation of single sideband is shown below, where DSP is double sideband, USB is upper sideband and LSP is lower sideband. USB shows the SSB modulation when the upper part of the sideband is filtered out. LSP shows the SSB modulation when the lower part of the sideband is filtered out. Efficiency of SSBSC. The efficiency of SSBSC is 100%. It is the most efficient type of amplitude modulation. The efficiency of DSBC, that is double sideband with carrier, is 33.33%. And the efficiency of DSBC, that is double sideband suppressed carrier, is 50%. Let's consider why is the efficiency of SSB is 100%. We know that the bandwidth of the SSB is reduced to half due to absence of extra sideband. It requires only one sideband for the efficient transmission of audio signals. In DSBSC, the efficiency was 50% due to the power divided between the two sidebands. Here, one sideband along with the carrier is suppressed. There is no such way for the power to get divided. Hence, the efficiency of SSBSC is 100%. Advantages of SSBSC. The advantages of SSB are as follows. First one is high efficiency, that is SSBSC has the efficiency of 100%. It is the most efficient amplitude modulation. Second one is less spectrum space, that is SSB occupies less spectrum space due to the presence of only single sideband. Third one is low signal fading. SSB has low fading compared to the other modulation type because of the narrow bandwidth. DSBSC has a wide bandwidth and thus suffers from high fading. Fourth one is low power consumption. SSB consumes low power due to the presence of suppressed carrier, high efficiency and single sideband. Fifth one is long distance transmission, that is SSB is used for long distance transmission due to its high efficiency and low power consumption. DSBSC is prepared for short distance transmission while SSBSC is prepared for long distance transmission. Disadvantage of SSBSC. The disadvantage of SSB are as follows. Complex receiver and transmitter. The SSB generation is complex and requires complex circuitry at the transmitter and the receiver. SSB avoids bandwidth increase due to the which power wastage occurs. It further leads to tuning. SSBSC also requires high frequency stability transmitter and receivers. Otherwise, the signal quality may get affected. Application of SSBSC. The application of SSBSC are listed as follows. Military communication, television communication, air communication, maritime communication, P2P, that is point-to-point communication, radio communication and radar communication. It is used in various applications that requires low power consumption, low bandwidth, and long distance transmission.
Electronics communication system. Electronic communication is any form of communication that's broadcast, transmitted, stored, or viewed using electronic media such as computers, phones, email, and video. Block diagram of communication system. 1. Information source. 2. Transmitter. 3. Channel. 4. Destination. 5. Receiver. 1. Information source. Following are message, letter, talk, email, sign. AM, FM, PM. This is angle of transmitter. 3. Channel. Medium, any unwanted signal which disturb original information. Destination. Destination convert an electrical message signal into its original form. 5. Receiver. Decoding and demodulation part. Classification of electronic communication system. First, wired communication and wireless communication. Data transfer speed. First, higher data speed. Second, lesser speed, slowly data transfer. Mobility. First, less mobile movable. Second, always movable. Security. First, more secure. Second, less secure. Unicast communication, broadcast communication. Data transmission. First, one sender to one receiver. Second, one sender to multiple receiver. Network traffic. First, less traffic. Second, more traffic. Example. First, telephone. Second, radio. 3. Cineplex, half duplex and full duplex. First, one-way communication flows in single direction. 2. Two-way communication but not simultaneous. Third, two-way communication simultaneously. First, more efficient. Second, less efficient. Third, high efficient. Thank you.
Hello, my name is Sandesh Patil. Today my topic for project is bandwidth. First up on definition of bandwidth. Bandwidth refers to the range of the frequencies over which a signal or a communication channel can transmit data effectively. Bandwidth for signal. For analog signals such as audio and radio signals, bandwidth refers to the range of frequencies that contain most of the signal's energy. In the context of the audio signals, bandwidth determines the range of audio frequencies. Relationship with data transmission. The greater bandwidth, the higher data transmission rate. In digital communication, data is measured in bits per second, BPS, or it's multiplied like per second, kbps, or megabyte per